Hi, this is another integration by parts example. In this case, we're going to start with some polynomial of x and then multiply it by a rational power of a linear function of x. So as usual, we need to make a really good first guess here. And the rule in these sort of situations is to copy the polynomial of x, and then we want to find an antiderivative for the rational power of a linear function of x. Ooh. This cube root sign is not our friend, so let's rewrite it. A cube root we can rewrite as a 1/3 power. And that's going to be a lot easier to work with. We know how to use the power rule in this situation. We have to do a little bit of substitution, right? We say, okay, pretend this was just an x. You'd get an antiderivative being, well, let's see, x to the 4/3. So we've got to add 1, and then you should multiply by 3/4 to compensate. And that almost does it, doesn't quite. Well, let's write down what we have. 5x minus 4 to the 4/3, and then we want to put a 3/4 here. The problem is, if we go to take the derivative, we have to use the chain rule. We're going to get an extra 5 out of this. So we better compensate by dividing by an extra 5. Okay, so this is going to be our guess. To check it, we're going to have to find the derivative, and we'll use the product rule as usual. So the derivative of x plus 1, no problem, that's a 1. Derivative here, well, let's see here. We'll copy the constant, 3 times 4 times 5, 3 over 4 times 5. We're going to have to bring this 4/3 down, and then we have 5x minus 4 to the 1/3. But then again, we have to use the chain rule on this. So we're going to have to multiply by an extra 5. Okay, well that's okay, because look what happens here. We have a 4 and a 4 that cancel, a 3 and a 3 that cancel, and a 5 and a 5 that cancel. Okay, so that's not too bad. Now we'll cross multiply. And when we do that, okay, the first term will be x plus 1 times 5x minus 4 to the 1/3. And that is what we wanted. Okay, again, that's the good news. The bad news is we're not done. We also have to add this direction. So this is going to give us a plus 1 times, all right, so this is 3/20, 5x minus 4 to the 4/3. All right, so we have what we want, but we have a little something more. We have to get rid of it, which means we're going to have to find an antiderivative for this to add to our guess. Oh, but this isn't so bad anymore. You don't have this extra x plus 1 bothering us. This is just some, well, power of 5x minus 4. We can use our substitution method on this. So first, I'm adding it, so up here I'm going to want to subtract. Okay, the 3/20 I just keep around. Now let's see, if I want to anti-differentiate something to the 4/3, I better write down something to the, well, 4/3 plus 1 is 7/3. Now, if I took the derivative, it would give me, well, first an extra 3/7. Yeah? Because this 7/3 comes down. All right, it gives you an extra 7/3. So I better compensate with a 3/7. Right? Because I just want 3/20, and I already have a 3/20. So I don't want that 7/3, so I compensate. But when I take the derivative, I'm also going to get an extra 5 because of the chain rule. So I better compensate for that too. I'll put a times 5 on the bottom here. So in total here, I'm going to get, let's see, 9 over, well, let's see, that's 35 times 20, that'd be 700. Anyhow, when I take the derivative, what happens? Okay, I can copy a minus, a 3/20, and then the 7/3 kills the 3/7. The extra 5 I get from here cancels that 5, and I'm left with 5x minus 4 to the 4/3. Notice those two cancel each other out. We've gotten rid of the extra garbage, and so this here is going to be an antiderivative for our original function. Not too bad.